Hello, I welcome you all. The problem reads the van travels over the hill described by y equals minus 1.5 times 10 to the power negative 3 x squared plus 15. If it has a constant speed of 75 feet per second, determine the x and the y components of the van's velocity and acceleration when x is equal to 50 feet. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Benam. Right, so we have a van that is traveling over the hill, and this hill is described by the function y is equal to negative 1.5 times 10 to the power negative 3x squared plus 15. This is a parabolic function, parabolic equation. So we are being told that the van has a constant speed of 75 feet per second, and we are being asked to determine the x and y components of the van's velocity and acceleration when x is equal to 50 feet. Of course, there are several ways of solving this particular problem. And for me, I'm going to use the n and the t coordinates. Okay, n and the t coordinates. So I'll be required to find the radius of curvature. This is one of the techniques, and not the only one. Not the only one. There are several techniques that you can use to solve this. I am going to solve this using this particular technique. Right. So let's indicate the details. Let's say this is 50 somewhere here. Let's say this is our point where 50 is. Right. Let's say 50 somewhere here. We use black. Let's say 50 meters is somewhere there, right? They told us 50 meters. So it's moving in this direction. The car is moving in this direction, right? So let's say that's 50. So let's say we have our velocity in that direction, right? And velocity in a curvilinear motion is always tangential, right? So that's one coordinate there, and then we have another one which is perpendicular, and this one we are going to call it, and it is pointed towards the it's perpendicular towards the center of the radius of curvature. So let's call this as our t, okay, and then we call this our n, okay, right. And then let me draw something also. I'll be required to find the angle, right? I'll need the angle. I'll need the angle somewhere there. I'll need the angle. This one is not very visible. Let me use black. I'll need the angle, maybe that angle there, like so. Okay. Right, there we go, something like that. I'll need this angle that I'm going to call this angle here. I'm going to call theta. Okay, I'll need that angle, and then we are being asked, mind you, to find x and y components. So our y is in that direction, like so. Okay, and our x is in that direction, like so. Okay, right, those are the positive coordinates, right? So let's call this as our y. We call this as our y prime, and then our x prime. This is where we intend to collect our data, right? Okay, and then what else? So we have this, so this angle is also going to be theta, right? This angle here is also going to be theta. Great. Okay, so there we go. We are going to indicate all this information later on. Let me just shorten this a little bit and just bring it there like so. This is our x prime. All right. So what do we start with, right? So we have y is equal to minus 1.5 by 10 to the power negative 3, okay, x squared plus 15. And y prime, okay, which is dy dx, right? That's our y prime, okay, which is our dy dx. This is equal to 2x. So 2x by that just becomes a minus 3 by 10 to the power negative 3 x. Okay, that's all. So y double prime is equal to like so, which is just equal to minus 3 by 10 to the 3. Okay, so here we go. So now let's find these values. We find this at that is y prime at x equal to 50. Okay, this is going to be equal to, let's plug it in. Why are we finding all this? This is going to help us to find the radius of curvature. So that's minus 3 by 10 to the power negative 3 times 50. So this gives us a minus 0.15. Great. So we know that rho, which is equal to radius, okay, which is equal to 1 plus y prime, then this squared, and everything to the power 3 over 2 or 1.5 divided by y double prime. Therefore, our rho is just going to be equal to 1 plus minus 0.15, and then we are squaring this. Then we are going to raise this to the power 1.5, and then everything divided by y double prime, which is negative 3 by 10 to the 3, right? Right. Therefore, our rho is just going to be equal to, this is the radius, we're taking the modulus. Let's multiply it. So we are saying that's 0.15 squared plus 1 to the power 1.5 divided by 3 times 10 to the power negative 3. Okay, so we're saying this is minus 344.65. Okay, which is just equal to 0.65 feet. So that is our radius. So our radius therefore is equal to, okay, we can leave it the way it is. So since we found this, we know that our VT, okay, is equal to 75 feet per second, and it is constant, right? So since we know our VT, we are able to calculate the components in the X and in the Y. So we are going to have one component in this direction. Let's write them down. We'll have one component in this direction. We'll have one component in this direction. We'll have another component in this direction. Okay. We'll have another component in this direction like this. So let's work them out. So this one here is this one here is Vx. This one here is Vy. Okay, so let's work them out. So we know that our Vx, okay, our Vx, let me say something. So we have velocity here, okay, and for curvilinear motion, velocity is always tangential to the curve, okay. And since our velocity is constant, we expect acceleration to also be equal to 0, right? You know that, right? Okay. It's going to be equal to 0 along the t-axis, along this axis, okay? Along the t-axis, acceleration is what? 0 along the t-axis. But along the n-axis, we are going to have acceleration here that we call centripetal acceleration. Centripetal acceleration, or center-seeking acceleration. Acceleration that seeks the center of the radius of curvature. Okay. So the tangential acceleration is going to be 0. Tangential acceleration is going to be 0 because our velocity is constant. But the normal acceleration is not equal to 0, right? There is going to be a value there, right? And this, there's going to be a value there, okay? Okay. So now, but we do have the velocity which is constant, and that velocity we can compute it in our axes that we are looking for, that is in the X and in the Y. So before we compute that, we need to find theta, right? So we know that y prime is equal to, we calculated y prime already, y prime is equal to at x equal to 50, this is equal to minus 0.15, and this is also equal to tan theta. All right, and therefore tan theta, you can compute it, is just going to be equal to tan inverse of minus 1.5. So tan inverse of minus 0.15, which gives us a minus 8.53 degrees. All right. Again, you don't have to, when you see a minus, usually when you get a positive angle, it means it's being measured counterclockwise from the positive x-axis. When you see it's negative, it means it's being measured clockwise, right? okay, clockwise, and you can see here this is clockwise, right? So this value, you can just show it. I can write this again like so. I'll write it like so. This is also equal to theta is equal to just 8.53. Then I'll show the direction. I'll show the direction. We are measuring this like so. Okay, we are measuring this like so. Okay, all right, there we go. So that's the angle there. Okay, therefore our Vx there is just going to be equal to Vt, because here we have Vt. Let me just show line there to just show to say we do have Vt in that direction. Okay, that one we have Vt there. Right, so Vx is just equal to Vt cos theta, where Vt, we already have it, is equal to what is our Vt? We calculated Vt somehow. Okay, no, it's given is 75 feet per second. So if we are to compute that, therefore our Vx we plug it in, we plug theta, and we get 75 cos 8.53. Okay, and this gives us a 74. This gives us a 74.17 feet per second. Okay, per second, and it's in this direction. All right, and then we have the other one. Let's work out the other one. Let me create a boundary there like so. Okay, create a boundary, and then we have Vy, which is equal to Vy. So this one we said is equal to Vt cos theta, and then this one, this is equal to Vt sine theta. So this one is Vt, this is Vt sine theta. Okay, where Vt we already said is 75, and theta is 8.53. Okay, therefore our Vy is just going to be equal to 75 sine 8.53, and this we get 11.12. Okay, feet per second, and this one is going up, right? It's going up. Right, so we are done with the components of velocity. So we need to find acceleration. So like we said, at is equal to dvt dt, and this is just going to be equal to 0. Okay, 0 feet per second squared. Then our an, okay, our an is just equal to Vt squared divided by rho. Okay, where we already know what Vt is 75, and then our rho is where is our rho? We calculated our rho somewhere. It is 344.6. 0.65. Therefore, our AN is just going to be equal to, let's compute it, that's 75 squared divided by 344.65. So we get a 16.32 feet per second squared. This is our AN. So our AN is in this direction. Let me just shorten this a little bit so that we have a little bit of space. Okay, this is N. So our AN is in this direction, like so. Alright. And this is AN. Okay. So we are going to have components from this AN. Okay, we'll have components. So we'll have components. Let's just show them. Let's show these components somewhere. I'll indicate them. Let's show the components. So we are going to have one component in the X in this direction. So this is the only one that will be contributing towards the X and the Y, because AT is 0, because VT is constant. Okay, so this one is AY, this one is AX. Okay, let's work them out. AX is just going to be equal to AN. Is going to be equal to AN sine theta, where theta is equal to 8.53 degrees, and AN, we calculated that already, it is just a 16.32, and therefore our AX is just going to be equal to, we have to compute this, so we have 16.32 sine 8.53, this we get a 2.42 feet per second squared, and is going the other direction. It's like so. Okay, and then we have AY, which is equal to AN cos theta, where theta is equal to 8.53, and then we have AN equal to 16.32. Therefore, AY is just going to be equal to 16.32 cos 8.53. Okay, and this we get a 16.14 feet per second squared. Okay, so we have done everything. Let me just write down the equations here. So this one is equal to AN cos theta, and this one is equal to AN sine theta. All right, so I think this is about it. Let's just outline the final solutions. So we have velocity, there we go, we have our velocity there in the X direction, and then we do have our velocity in the Y direction, there we go. And then we do have acceleration in the x direction. There we go. And then we do have this one I didn't show. This acceleration is coming down like so. Okay, there we go. Right. So I think this is about it. This is one way of solving this particular problem. This is one of the ways, and I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.